problems. Either it was for academic or industry. Um, uh, After my PhD, that was completed in 2021. I came to Pakistan and I joined UCP Lahore for as a assistant professor, and I worked for 1 semester there, and I got a postdoc contract. I actually applied for a project in South Korea, and I got that project. So I preferred to work on the project, and I moved back to South Korea. I completed that project in 1 year, and it was purely based on federated machine learning. My bachelor's was from UT Peshawar, and my major was computer system engineering. I have done my master's, my MS from same university, UT Peshawar, and my major was same. During my master's, I worked on bioinformatics problem, and I solved Smith-Waterman algorithm on GPUs for protein thickness alignment. I worked as a lecturer in Superior University for 2 years, and before that, yeah, I worked as a lecturer in Lahore University in Lahore for 2 years. And after my bachelor's, I worked as a iOS application developer, specifically for iPhones, for 4 years. I will I would prefer to talk about my research so far. I have some selected papers which I worked on during my PhD. I published those, so it's better to talk about those projects. So I'm sharing my screen with you to show you the presentation which I prepared for this demonstration. I will talk for about 5 papers. Probably I have a time constraint, but my first paper, which is published recently, and that is on federated machine learning. So I will talk about that paper, and then I will talk about ESL's quick situation avoidance learning system, which I developed during my PhD. I work on Pashto, the language for Pashto handwritten character classification. I made my own data set, Pashto data set, and I created my own CNN model, and I applied that model to that data set, and I got benchmark results. After that, I will show you that a different project that was based on human sentiment and activity detection. And after that, I will present my own conclusion network. There was a benchmark for me to get graduated and get the PhD. And I will my own now CN model, and I named FabNet, and I applied that to his pathological image data sets. So the first paper which is published, and it is based on federated learning based analysis of human sentiment and physical activity in natural disaster. In this paper, in this project, I compared centralized learning and federated-based learning. And I found that both have ups and downs, and both are nearly identical. The results are nearly identical. So, what is federated machine learning? Federated machine learning, as you know, you have native devices which are called nodes, and every node you have either you can have one model or can have different models, and you train those models on the native nodes. Those models are called native models, and you actually send the 10 parameters to aggregator, where you have different aggregation techniques. I use fed average technique as a aggregation for aggregation of these models. It aggregates, update the models, and send back the models to the trained parameters to the nodes, and the nodes are synchronized. For that, I present the results, and you can say I have different methods to evaluate these models. Federated learning is centralized learning. The one method is Wood entropy, mixed segment, margin sampling, census entropy sampling, and least confidence. And I recorded the precision recall and F1 score for federated learning and centralized learning. I found that both have identical, both have its own trade-offs. The second paper which I want to present is to talk about my learning system for earthquake disaster avoidance. It was a project I got from Korean GeoICT, and in this model I used YOLO. It's actually it has done in 2018, so the year was a very now kind of detection model at that time, and so I proposed my own system. The architecture of that model is presented here. The paper was published in Cognitive System Research. There is published elsewhere. In this project, I have to detect and I have to show in runtime the audience, the users, that which particular object can have a potential harm during a quick situation. So I had 32 different objects which are actually more common in Korean household or indoor environments. I had 19,200 images dataset. I created that dataset by my own. Well, it was like a Korean indoor environment. These are some objects and some classes which are like some objects can be collapsed, some objects can be breakable, some objects can drop, and some objects can hinder. And these were the result for images, and this is the result for a real time video. Like it was like yield 10 FPS to be very precise. This is performance of server where HRM is deployed. The dataset and the train parameters can be found in my lab URL. So every is open for research purpose. The second research which I want to present is partial handwritten characters based on deep learning. I made my own dataset that was called POHA. I applied my own created developed CNN. It was an optimal CNN, a very lightweight at that time, and I feed data set to that model, and it gave me a very good result of accuracy. Like it was 99.6% accuracy. That time I applied different data sets like O2 data sets, MEs, and all um, data sets which I fed. It gave me superseded the current benchmarks at that time, and it set its own benchmark. So and I was the first person as far as I know who have created his own personal character dataset, handwritten character dataset. Use of there were many people who helped me in creating the dataset, and I applied convolutional neural network for the first time to personal handwritten characters. And these are some results for comparison results which I after that which I so this is the snippets of my dataset. The methodology where I remove the noise by medium filters and smoothing by Chandler by pre-processing, and I fed it to my proposal and I classify the model, the characters. This is the proposed convolutional neural network. Like every detail of each layer is provided. You can say there are 9,532 parameters. It's very lightweight model that gave me a very good result. These were some matrices, some graphs in comparison with ResNet 14 and ResNet 34, and I applied to I compared to mobile net and different kind of models which were available and which were benchmarked at that time. I got these results, which are you can see it's superseding the benchmarks at the time. The computer address for my project. And they were like I compared my model with Inception, version 3, mobile and Tensnet 2.1 and ResNet 50, ResNet 14, ResNet 34. And I fed in the send to datasets, and the neural network worked very fine using those datasets as well. There were some correct classification and there were some incorrect classifications, like you can see false positive and false negatives of this model. The third paper which I wanted to discuss is human sentiment activities recognition disaster situation based on deep learning, where I fused YOLO with my own human tracker. I developed a human tracker, human count model that can count humans in a fluid environment. So and it actually assigns an identity score even if the object is occluded. So this was the methodology, and these were the architectures of YOLO and my own developed human tracker architecture. I fused those two models and it gave me results like this, where I can count people and their current situation, what they're feeling, and what is this, how many humans are there in this in a particular scene. It what we find using runtime cameras. And last, I want to talk about my own CNN model I named Fabnet, and it worked very fine on his pathological images. I applied two kind of cancer cells, breast cancers and colorectal cancers. this is a picture of my model. Um, this is it's actually based on block. Every block consists of like the inner architecture of every block is like this, and it gave me a very fine result. I compared those results with the benchmark model available at the time, and you can see fine. It gives me very good result, experimental results. There are some confusion matrices, some experimental results, and that's it. Thank you much for the time. Thank you.